Insights session today. I'm really excited to take you through this, and I hope we get to engage and learn from each other as we go on. So the title for today's webinar is Data Analysis Techniques. This is the second webinar we are doing for Insights. We've previously done basics and some introduction. So now it's like a build up to that, but I also just try to peruse through a couple of basics that I covered in the previous webinar. Thank you. So as we go on, you'll be engaged on the chat box. So just feel comfortable to key in your questions on the chat box as we go on, and then that will be addressed, and I'll also try and address when I get to finish the webinar soon, early enough. So the objective of the webinar, we're going to look at an introduction to ArcGIS Insights, the capabilities, and the most interesting bit, which is the data analysis and visualization techniques within ArcGIS Insights. And then you'll actually transform a data set that I have and see how Insights is able to convert that into a very insightful workbook or series of cards. So for the presentation structure, we'll do the slides, and then after the slides, we'll have a demo. And the slides will cover the intro and the data visualization techniques, and then after that, we'll all go to the actual exercise of creating an Insights workbook. Okay, so we'll get started. Okay, so ArcGIS Insights is fairly new. It's actually a fairly new application. It's a web-based app, and the main goal is making spatial analysis simple. That's the main inspiration behind Insights. Some of the key advantages or capabilities that it has is the fact that it's able to incorporate data across multiple platforms. Talk about flat files like Microsoft Excel, it's able to consume that. So that's one key powerful component about Insights, the fact that it can consume spatial and non-spatial data. So if you have an Excel sheet, you have a traditional GIS file like shape files, it's able to consume that information. If you're in an organization and you're running with enterprise databases, so that means SAP or Microsoft SQL, then it's also able to consume that and create workbooks out of it. So that makes it really powerful in terms of the data sets it can consume within the workbook. The other good advantage is the fact that it works directly with fields. This will probably make sense when we are doing the demos. I'll explain that, what I mean by you're directly interacting with your data set on the fly within that particular application. And then the other bit is we are also supporting other components that are available in desktop. Insights is also able to manipulate that. So components like table relationships, when you want to do joins, Insights can support that. So the other very interesting component is, I'd mentioned initially the data that it can use. So initially, we were supporting ArcGIS we're really powerful with location information. Now, what we are also integrating into Insights is allowing you to integrate spatial data, which ideally is what any GIS tool does. Now, we are also bringing you access to open data. We are giving you access to business data, non-spatial data, and open science data, data science tools. So Insights is now able to pool data. If you have data that's an Excel sheet, which ideally is non-spatial, it consumes that. You have spatial data, you can relate those two, your spatial and your non-spatial file. But if you also feel like you don't really need the spatial, you're not limited. You can always work with a non-spatial file within Insights. Then for those who like scripting and you use Python and R, this is the tool for you. You're also able to write your scripts within Insights and extend it to as many capabilities as possible within your script. So we'll get into how it works, or the components that it has. So we have three ways you can run it. So Insights has a desktop component. So initially we just used to have the web version, right? But now we've extended that. If you're more comfortable with working with a desktop, you can download that and use the desktop version. Then the other bit is you can either access it through ArcGIS Online or ArcGIS Enterprise. I'll give a brief summary or a brief overview of our portals. So what happens within the Esri ArcGIS platform is we're an end-to-end product. It's a pipeline that where an input for one becomes an output from one product becomes an input from another product. Now the life of our system is a portal. So that portal, we have two portals. We have either ArcGIS Online or ArcGIS Enterprise. So those two are what enables people to collaborate, people to access data anywhere, anytime. That's the power of WebGIS. And our WebGIS is powered by either an enterprise account or ArcGIS Online. So that's the same way Insights runs. You can either get it through an enterprise account or through an ArcGIS Online account. The only difference between these two is the hosting. For enterprise, you're giving you flexible deployment, right? So that means if you're more comfortable with hosting your data at a data center you're comfortable with, or hosting it in your own private cloud or your own physical server, then enterprise is what you'd ideally go for. The other option is convenience for people who don't want to be concerned on server maintenance, updates, troubleshooting. So we have another option for that, which is ArcGIS Online. So both of those work the same way, have the same functionality. The insights in both have almost similar functionalities. So that's ideally how you get to access insights, through any of those two platforms. Okay, so I'll get into the insights bit and how it works and what it's made up of. So what you're looking at on the screen are screenshots from products that are coming from Insights, from an Insights workbook that has been created. And each individual screenshot you're seeing, we call them cards. So Insights works with cards. So cards are ideally any individual infographic you have created. So you notice you have you have maps, you have heat maps, you have link charts, you have tree maps. So all those are different visualizations that Insights can create and you can come up with within the platform. And all this, again, we initially said that the data from what this emanates from is either from a database, a flat file like an Excel sheet, or a GIS file. And the advantage really is finding answers and driving impactful decisions within your organization through these cards that you're seeing on your screen. And some of the capabilities would be, all these cards are ideally interactive and linked. So if you want to see how, for example, one relationship affects a map, then the cards are able to strongly display that on your screen. And I'll also be able to show that on the demo on what we mean by linking your cards and making them interactive and responsive as you're doing your analysis. So we'll also look at the different ways or the different sources of data that all these cards get the data from, right? So the examples that given initially where the data, it picks data from either spatial files or from tabular data. So if your organization is running on Oracle, you're running on SAP, you're running on Microsoft SQL, then you can always plug into Insights as a portal for you to get analytics from your data or within your data. So I want us to look at the different ways we can visualize data. Thought this would be really useful before we start doing the demo. So these are mainly, when you talk about data visualization, the main goal is driving insights and just going beyond mapping, right? So initially, before we got into the world of data science and all that, it used to be traditional GIS applications where you just cartography, right? You just create a map and that's it. But now that we have all these emergent technologies that are happening, things like big data, then there's a need for us to crunch the numbers and have an application that can do that on the fly and give you insights as you're working with your data. So we'll look at the different common ways of visualizing data. The very first one, we're calling it bar graphs or bar charts. And what you're looking at is an example of a bar chart. And we normally use bar charts when you want to when you're working with qualitative data. So in an instance where you're looking at, for example, the bar chart here shows maize production across Kenya, right? So normally how a bar chart works is that one axis will contain categorical values, the other axis will contain numerical values. So for categorical values, these are like nominal values, values that we cannot quantify. So things like counties, things like states, things like words, things like countries, those are categorical values. And so as we go on, when I use categorical values, that's ideally what I mean. Categorical values are nominal values that are not quantitative. And then numerical values are now statistics, numbers that you can be able to measure and see how high or how low they are. So in an instance where you need to compare highs and lows in your data, then a bar chart would be the way to go to be able to show you the differences in the highs and lows. The other one is a tree map. Tree maps are not very common, but recently many applications have started really making it as a common visualization tool. And the main advantage of tree maps is if you want to show hierarchy of your data as a proportion of all the data sets you have. So the screenshots you're looking at was a file I was creating to just showcase COVID-19 numbers across Africa. So you notice that the tree map is able to like list for you the top few countries. Like you can see South Africa as like the biggest size of that tree map as a proportion of the entire size. And then as you go on, the numbers and the sizes keep dropping based on the quantities and the numbers in that particular country. So tree maps are normally good for that. And then the other thing is bubble charts. Bubble charts also, so it's ideally the same data set, the same screenshot, but I'm just representing it as bubble charts. So bubble charts also do the same thing where you represent values as circles, right? And the circles are randomly placed. So bigger circles ideally have more quantities or more numbers than smaller circles. But however, each of these technique has, they have their own disclaimers. So like for bubble charts, if you have too many categories, then you'd probably it would probably be fair for you to go with bar charts, right? If you have very many categories. Like you notice on my screenshot, you get to see South Africa, Morocco, Egypt, then the rest are like really small unless it's interactive and you can move your cursor. So it can become tricky for a consumer or an end user to tell which circle is bigger than the other. Some circles have disappeared. So if you have so many categories, then go with the bar chart, right? It will always list that for you, as opposed to what bubble charts can do. So that's the disclaimer for bubble chart. And also they're probably less accurate than bar charts compared based on how they visualize the information. It's really tricky for when I show you a bar chart and I show you the same representation from a bar chart, you can literally pick as you go, like just at a glance that this one is longer than the other. But for the bubble chart, it's almost the same challenge with pie charts. You can't tell which circle is bigger than the other. You can't tell which slice is bigger than the other, which brings us to the donut chart, or those who've used pie charts before, it's almost the same thing. Donut charts have just like a bigger, is it like a bigger angle where you're starting it from. But the donut charts are also really good for visualizing. They're used to visualize qualitative information. So qualitative almost falls as categorical data, right? So like this one shows the different types of crimes that exist within a certain city, right? So you have burglary, motor vehicle theft, robbery. Again, the disadvantage of the disclaimer for donut charts and pie charts, because they're basically the same thing, is if you have a lot of categories, then it becomes tricky for the end user to tell which slice is bigger than the other. And when it comes to data visualization techniques and analysis, your goal should always be to make someone understand what's going on at a glance without me having to wonder, okay, which slice is bigger? Is the burglary slice bigger than the robbery? Or like you wouldn't want your end user to be in such a situation. So, but if you have between three categories to 8 proportions or 8 categories, then you can always use them. But if your classes go beyond 8 different categories, then you might probably want to consider another way of visualizing that particular file. Then we have chord diagrams. Chord diagrams are also really good, especially when you want to understand categorical data and how they're related. So relationships between categorical files. Let me look for an example. Yeah, also, okay. So when you're talking about purchasing power, and the supermarket wants to understand who buys our goods more often and at what times, right? So normally, if it's a supermarket, then they probably have a database of customers, right? And they have components like the gender and the age, but then they also have the goods that people buy. So categorical information, for example, gender and the type of item I bought as a user, those two are different, are two categorical data, right? There's no sales information there. That's just categories, there's no numbers involved. So in such a situation, when you want to understand, is there a relationship between gender and the items that are bought in this supermarket? So do we have like who buys most books, who buys most, I don't know, milk or handbags? And you want to understand, is it men who buy that or the other gender? Then chord diagrams should be able to understand that kind of relationship. That's just an example, but you can cut across any industry, right? You want to understand which motor vehicle, which road classes do motor vehicles prefer, right? Which types of motor vehicles? You have trucks, you have saloon cars, and then the road is rough road, the other road is tarmac. So when you want to understand these two relationships, a chord diagram is the way to go. So anytime you have categorical values, you want to know how they are related, then a chord diagram would pick up that relationship for you. Then we have a heat chart. A heat chart is also really interesting. And what it basically does, it shows you frequency, the number of times a value appears within a certain record or within a certain column. So so the reason why it's called a heat chart is you're kind of seeing like where the colors are really dark, then there's more frequency at that particular point than where it's light. So it's like a heat basically, where it's like a hot point, then it goes and becomes colder as you go, as the colors become lighter. Again, it's good for using it, but sometimes when you want to see really local details about a particular value, then it wouldn't be the way to go, because it has classified all the values, right? So you wouldn't know by how much or by how high this place is high or low. So you can't really quantify that, which might sometimes be really tricky because it's hidden within the heat chart. And then last but not least is a histogram. A histogram is really good. I think, especially when you want to understand how values are distributed in your file. Then before you even start analysis, it's very important for you to understand, is your data normally distributed? Is your data skewed to the right or skewed to the left? Then a histogram would be able to show you that. It's purely for quantitative data, because you want to understand if it's population, how is it distributed across the country? Is it a normal distribution where, for a normal distribution, it's like a bell, where you can tell under that curve, it can form like a bell. Is it skewed to the right, where values are skewed on one side of the chart or on the other side? So when you want to understand how values are distributed from the mean, the median, the standard deviation, or the kurtosis is how different it's how different the tail of your data is from normal distribution, then it's able to give you that information. I hope as we maybe in the next version of the webinar in Insights, we probably dive deep in spatial data science and looking at kurtosis, R squared, and all those values that enable you to understand the distribution and the performance of your model, of your spatial model. But basically, a histogram is used for quantitative data, and it enables you to understand how values are distributed across your map or across your data set. Okay, so I'll do a demo using some of these common tools that I have just mentioned. So just give me 1 minute. I hope everyone can see my screen. Victor, can you confirm that? Okay. Okay, so Insights, so this is my ArcGIS Online account. I'll run on the Insights version for ArcGIS Online. But if, again, you remember I mentioned if you have ArcGIS Enterprise, you can use ArcGIS Enterprise. So you notice if I type in arcgis.com, that's the URL for ArcGIS Online. There are people who prefer to cram the URL, but it's really not necessary. As soon as when you just type arcgis.com, and it takes you here and you click on sign in, it's smart enough to pick that this username is linked to a certain account. So if I sign into this account and click on sign in, it redirects to the URL of my organization. So it's if you don't have the URL, you can always just type the generic one, arcgis.com, sign in, it will redirect to your own account. So this is what ArcGIS Online looks like. So for now, I'll just go into Insights. So up here at the top corner, not really at the top corner, up here there are like menu bars where you have home, gallery, maps, in notebook, groups, content, and organization. Again, that's standard, regardless of which account you've logged into. That's the standard. Those are the standard menus you have access to. So for Insights, on the top right, I think on my side, it's like the top right. I think on your end, it's left. So you notice when you click on this icon, it shows you the list of applications you have access to, right? And Insights happens to be one of them. This is dependent on the licensing that you've been given by your administrator. So in an instance where you're sure you have Insights, but you can't see it here, so basically if you can't access it here, then that means they've not assigned to you a license. You just reach out to your admin, then they can assign for you an Insights license. It's a very fast process. Within seconds, you'll have your Insights. So this is what the landing page looks like, where you have up here recent workbooks. It lists for you the recent workbooks I have created as a user. Then down here, it shows you interesting statistics and news about ArcGIS Insights, right? You can see here the most viewed pages here. This page had like half an M views. So it shows you like those statistics within your, like there's this model, school outreach model had 87 views. And then you keep scrolling, it's news about most recent workbooks and packages that have ever been created on Insights. And then on the right, on the left of my screen, notice I have the home, workbook, models, data sets, connections, pages, and themes. So this is everything that the workbook is made up of. So when you're talking about a workbook, remember I initially said on the previous on the slides that Insights work with cards. So all cards are hosted within a workbook. So that's why we are saying you're creating a workbook. So that then inside that workbook is where you have the cards and the analytics you've created from ArcGIS Insights. So we'll come here on workbook and create a new workbook. So in workbooks, I'll click on new workbook up here. You can also want to import, but I won't import any because there's no file I've created or downloaded from here. So I'll just go on new workbook. Okay, so we'll just give it some time. Okay, good. So as it does that, then automatically it brings this page for what you want to add onto your page. So this is what it looks like, the empty workbook. We've not created anything. Now up here, there's like the different commands. There's like select data, these creating charts, all these save, but you notice most of them are inactive because I haven't loaded any data. So for this demo, I decided I wanted us to use this data from the CDC, which is COVID-19 data. Thought we might as well just use data that we are all conversant with. So I'll use this COVID-19 data that's normally posted on the European Union, on the European CDC site, which is updated I think every day. This was updated yesterday. So I'll just click on it and then it will download it. So it's an Excel sheet. I think we'll start, I wanted us to work with an nonspatial file and see how Insight is able to work on it and create other functionality within that file. So this is what the file looks like, the Excel sheet we've just downloaded. I think I'll share this link as well on the chat box for those people who would be interested in COVID-19 stats across the globe. They're normally, that site is very accurate in the statistics it gives and how often it updates that information. So this is what the Excel sheet looks like. So it has all these columns, the date it was reported, the day, the month, the year, the cases, the deaths, countries, and all that, including the population. So they've also given us population data for 2019 for all the countries. So this is the entire globe. So we'll work with this file. So for a start, we'll go back to Insights. So this is our page. Then we'll click on the plus. So the plus is for adding data. So I'll click on the plus. And then for this particular scenario, I'm uploading a file, but there is Living Atlas. If you're getting data from there, there's uploading the file, if that's what we are going for currently. And then there's also SharePoint, right? For those who are running on Office 365 and you have data sets or links that are attached to SharePoint, then you can always just get the unique IDs and identify about your what is it called, your SharePoint connection in that particular file, and then you're able to pull it directly. And then there's also OneDrive, and then of course your ArcGIS Online account. So for this particular example, we'll go to upload file, browse to my computer, and then we'll pick the Insights COVID-19 data. So this is the one, COVID-19 geographic distribution worldwide. I'll open it. So when you're uploading from file, remember it's showing you here what you have access to, what you can upload: Excel sheets, CSV files, shape files, JSON files. So I'll click on add. Okay, so that's done. So you notice it lists it on the right side, on the right-hand side. Now, what I really like, one of the favorite features I like about Insight is the fact that it's able to categorize my data for me, right? So you notice that just by adding the data, it's already classified. Like next to this icon, there's like a clock icon to show you this is a date icon. This is a date data set. There's this, is this like a number three? Is it like a number three that's facing on the other side? So when every time when you see this particular data set, this particular icon, you know that this is numerical data. And then there's now the chart, the icon that looks like a chart, then that's like a bar chart. So you know that that's categorical data. I don't know if you guys can see the icon that I'm talking. Let me just zoom in. Yeah, awesome. So you notice that this is the icon here. This is like a time thing. When you scroll down, the year for you, it has put it as a categorical field. This means it's categorical. This means it's numerical, right? So it does that for you. So if you have so many fields, it's able to classify that for you and give you all that information. So let me just close my magnifier. I hope everyone has seen the icons. And then the other thing also is in an instance where, for example, you have these cases, you're also at liberty to change the type of field you have, right? Notice that when I click on this icon, I can decide to change the number of cases globally from a number to a string or a ratio. So in an instance where you need to do like light cleaning, you don't have to go back to your Excel sheet. All that is catered for within the platform. So we'll start by looking at some of the insights you can get from this file. Let's start with something like the date these cases were reported. So let's pick these two. I want to look at the date and the cases we've had to just see how that changes. Then I want you to note what happens when you come here. Can you note that I have three places I can drop this, the dates and the cases, right? I can either drop it to a map, but it's inactive, it's grayed out, meaning maps are not supported on what I've currently dropped. And then there's a time series, and then there's a table. The table is also grayed out. So what's highlighted is time series. So it kind of also gives you a guide. It's like a wizard that tells you, okay, for this particular, when it's date and numerics, then you need to do a line series, right? Because that's how we understand how data is changing over time. So that's what it looks like. That's the distribution of COVID-19 cases globally, right? I've used the cases, but if you want to use the deaths, I'll just do the same thing for deaths. Notice it will almost draw the same graph. I'll just delete one. I think I just use one line series. So those are the dates. You can clearly tell where we had the peak deaths across the globe, right? Between, is that April 12th to April 19th? Yeah. And that's, so let me just delete this. I don't think we need to. So that's one card. So now we are looking at cases and the dates reported. Now on this other bit of the insights card, you notice that down here there's an option of grouping. So I might decide that I want to see the cases of COVID-19 per continent or per country, depending on what I want to group it by. Now, if I decide to go with something like continents, right? Let's look at continents. So it's able to amplify that and give you the breakdown of the time series per continent on the cases that we had. And then also you notice that on this side, there is cases, right? It's showing you that we are looking at cases, and the calculation is doing is average. You're again at liberty to say, I don't want the average number of cases, I want the sum of cases. So that's why when we say you're interacting directly with the fields, that's what we mean. It's like, okay, I don't want sum, I want an average. It sums that up for you and crunches the numbers and gives you the line series on the fly as you're doing that. So now you're looking at COVID-19 cases globally and per continent, right? So you can clearly tell, I think the red is America, this other one is Europe, right? And you can clearly tell that Europe had a spike again between October 25th and November 1st, right? 25th October and November 1st. So you're already getting insights from that file. Now the other bit, I also want us to look at something else. So that's the time series. Let's look at the distribution of these cases by countries. So we have this file here called countries. So you can pick countries and cases. Again, when you come to drop your card, it tells you all, like when now you notice map again is grayed out, and I'll explain why map is grayed out on all this. But table is active. So if I drop it on the table, it summarizes for me the cases across the globe for each country. Afghanistan, 41,000. Albania, 21,000. Algeria, 58,000, right? Now, I want to change that. So if you want to change that, I'll just come here and changed the visualization chart, and maybe I just want to see a bubble chart, right? To see which countries are still appearing as the highest cases. And then from that, remember we said that bubble charts are really good, but if you have a lot of categories, then it can be a bit limiting. But from here, you can clearly tell the countries that have the highest cases, right? The US, Brazil, India, I think there's an F here, France, there's Argentina, and there's Spain, right? So, and then you can also decide to change this. I'd also talked about a tree map, which normally shows you hierarchy, right? It will like list for you the highest countries and then all the way to the last country where the boxes are like really small. But from here, you can tell like the top 10 countries, right? There's the US and India, then there's Brazil, Russia, France, Spain, like, so it lists that for you as the, I want us to try something interesting. I really also like about Insights. So currently, the reason why like the map is, like if I want to see the cases on a map, you notice I can't do that, right? Map is grayed out is because it's an unspatial file, right? It's a flat file. It's an Excel sheet we picked from online, and that's what we're using to visualize. So we want to make this map, this file spatial. How do we go about that? So the first thing we'll do is I'll come here on add data, and then I'll look for data on world countries or world boundaries, because we have like 53 or 54 countries, and I'm sure the CDC Excel sheet has the same, right? So I'll just pick one of them. And then what's really also interesting is now it's like the little bits and pieces of the platform are coming together. So now what I'm searching the data on is I now have direct access to it. By just coming here and clicking world, I'm able to pull that. So in another, maybe another workflow would have been going to Google, looking for a shapefile, downloading it, zipping it, like it's a whole other workflow. But now with Insight, it's able to integrate data from all these bits of the platforms that you have, and you're able to bring it into your workbook to really have comprehensive integrated information that is efficient and makes you get your work done in good time. So this file has the region, the country, and the administrative codes. So since we have countries of the world, I'll pick country. That's the only layer I want. Then I'll say add. So that's a spatial file I've added. Automatically, it will add a map card onto the map as soon as you add a spatial file. So now we need to link the map to the COVID-19 CDC cases and make their data spatial and more intelligent spatially. So we'll come here onto the countries. That's the file we've added. And then we also have the COVID-19 file. I hope everyone can see this. Just don't want anyone to miss. Okay, so we have here the COVID-19 table. So I'll just come here and say enable location. So I'm enabling and making this file, you know, converting it to a spatial file. So on the location type, we are not using coordinates, right? Because the Excel sheet does not have coordinates, and these are boundaries. So we rarely use coordinates for boundaries. So we are using geography. And then we'll say on the geography, we are using fields. So it will use matching fields in both the two files. So in our file, we know that it's countries. So we have here, I want to show you which one that is. So there is this column here in the Excel sheet called countries and territories, where you have Afghanistan all the way to Z. So we'll just pick that, countries and territories, as the matching field. And on this other one, we're picking the country. So Insights will look at that data and see if they're matching, if the columns are actually matching. So you notice it's like close to like 80% based match. And the reason why it's not 100 is not all countries are represented here, because not all of them have COVID-19 cases. The other is probably spelling errors in either one of them. Not really errors, but how they've spelled it, or some have hyphens. So sometimes those also would influence how your files match. But again, for accurate 100% matching, you might want to pick the file, clean it up still on ArcGIS Online, or pull it down, or use your own local files if you're using local data. So that's it. Now our map is enabled. So now the next thing we'll do is, let's see how the map now responds, right? So we have here the map. So let's try and add cases onto this map. Let's just drag cases. Okay, I can even drag it onto one. Notice now map is active, right? So now map, chart, and table, all of them are currently active. And if I drop cases onto map, it will map out the cases for me. And I can do the same thing onto this other map, the one that we just pulled. So when you look at these cases, we now have a map that is now able to look at the COVID-19 cases globally. I think we don't need this card. So I want us to look at cases and deaths and see. So let's drag deaths. You can have two maps or you can have one map represent cases and deaths. But I want us to just look first if there's a difference in if the same regions that have cases are the same regions that have the deaths. Yeah, I think it's almost the same thing. Yeah, like Brazil has like the highest number of deaths, but it also has the highest number of cases. Now let's try and do something a bit smart on these two maps. Let's represent the cases and the deaths in one map, right? Instead of having two unnecessary maps when they can all be merged into one file. So I'll just drag this and add it as a new layer. So this map has deaths and cases, which you can compare one to one. So I'll delete this, and then let's just change the symbology for this file, right? So we'll just make one a different color. So we can keep the sum of deaths. Okay, we can change this. Let's go to the color. Let's pick a different color that's contrasting with orange. I'll just pick a random color. Oh boy, okay, let's make it a bit transparent. Can you guys see? Then let's reduce the size. I think I should use like a more intense color. Then I'll do the same thing for the cases because I've reduced the size to 24. Let's just use the same sizes so that we can see if the case, which one is more in all these locations. I think it's 24, yeah. So when you look at this, wait, is it visible? Can you guys tell? Okay, let me zoom into one region. But you can tell like the orange circle is sort of, just use this and see if there's a difference between cases and deaths. You can see like, for example, this, is it Belarus? You can see like the orange circle is bigger. In all of them, actually, the orange is like appears outside the blue, meaning that the sum of cases is always bigger than the sum of deaths globally. So that's one map that represents that. Now let's look at COVID-19 proportion as a percentage of the entire global population, which again, let's normalize this data. So normally when it comes to data analysis techniques or visualization, it's always recommended for you not to use raw values. So in a good example is what? When you're talking about employment, right? It's smarter and more insightful for you to display a map that shows employment rates than for you to show a map that just shows employed people, right? Because the rate gives government, policymakers, and decision makers an idea of what percentage of the population are employed. So we'll do the same thing here. We look at COVID-19 cases as a percentage of the entire population to just see, like, are we saying, like, for example, South America is a hotspot because the population is just huge and that's why, or is it actually that there are actually more infections per 100 people or per 1,000 people? So Insight is able to generate for you that. Let's calculate a couple of fields here. So let's go to our table. Let's view the table. So this is the Excel sheet we've just downloaded, and we want to add a field. Let's add a field for rates. So I'll click on plus. I think it's added it here. I'll call it rate. Currently it's null, so let's calculate it. So here the rate is the cases, COVID-19 cases, divide by the total population, the total global population per region. And then I think the rate is normally per 1,000 people or per 10,000 people. I think CDC does it per, I think it's per 100,000, but I'll just use a random figure for now to just show you that you can actually generate fields on the fly and do calculations. You don't have to go back to Excel to calculate fields within Insights. So we'll just give it some time. Good, so that's the rate. calculated for all the countries that we have, 53 or 54. So I'll close this. Now let's map out the rate so that we can actually tell, are the hotspots still appearing as hotspots when you map out the rate? So you notice now the rate has been added here as a new field. So I'll select it. Then I'll just drag it to a new map. And then I think for this, let's change the symbol and use something else other than the circles. Let's create a choropleth. So let's go here and change this and look at the counts and amounts for each region. So there you have it. So why we are viewing rate is because we want to see it as a percentage. You notice that places that were appearing as hotspots are no longer hotspots, right? Because the number of infections per 10,000 people or the rate of infection is not as high as we think, right? So you notice that, for example, let's look here. Like this here looks like it has a lot of cases, but you look at the rate in Mexico as a percentage of the entire population, then it's not really that. Some of them are not really appearing as hotspots as we may think, right? Because we are looking at, I think when we are reporting, we're looking at like sum of cases and sum of deaths, but we're not looking at that as a percentage of the entire population. Like, do we actually have these infections? But when you look at the rate, which is as a percentage of the population, then it starts to give you an idea of you know, this distribution of cases per 10,000 people. So that's again on that. Then the other thing I'll do is, yeah, I think I wanted to show you guys how to just visualize your histogram and distribution of values. So for example, if I pick cases or deaths, if I drag this to another chart, I can always view a histogram which has appeared there. So the purpose of this is just to look at how your data is distributed. What is the mean value? What is the mode? What is the median? And I think I'd recommend, when you're doing analysis and you have such statistics, it's always good practice to look at the distribution of your values. And you can notice that this is a very skewed histogram. And of course, this is expected because it's a pandemic. It's not population distribution where you expect a normal curve or, so this, of course, you'd expect this for factors like, for things like epidemiology and diseases and disease spread, then the curve would always be, you know, a bit quite skewed on one side. Then the other thing I also want to demonstrate is can use deaths or cases. I think box plots are also something that's really worth exploring. So I'll use a box plot and just explain what that means. You don't really need it, but I think it's really important for spatial data analysis when you really want to understand what's happening in your data set. Okay, let me just change this. Let's use deaths by countries, then use a box plot. Okay, just change it. Yeah, so let's change this to a box plot. Then I'll just explain why box plots are important. It will probably be cluttered, but we'll filter it out. But the reason why we use box plots is that it's able to tell you in your data areas or regions that had spikes that were really different from the usual. So the box plot would show you minimum and maximum values, but it would also show you outliers. So it's a really good way of looking at outliers and, yeah, basically outliers. Like you can see here, like there's an outlier up here in Argentina, and you'd probably, as a data scientist, you'd want to know, okay, why is there an outlier, and try to understand. So box plots are really good for understanding outliers or things that seem really off on your data, whether there was a spike, or sometimes it can be like something that's the opposite of spike, like it's really minimal. And then one last but not least, all these charts actually would support interactivity. So like, for example, if I come here and pick, like, let me see if it's interactive now. Yeah, so notice that when you pick any country, it would basically list, I think it's like here at this very box, and it will also show you that this is in Africa, and then the cases that would fall under that. I think for us to make it more interactive, let me put a filter. think we'd be able to understand the cases in Africa better with filters than selecting each country. So let's go here and add a filter. So it's added a filter. Let's scroll down. That's our filter. This is filter by, we use continent or country. Let's see which one works best. That's our filter. We'll add it. We want to use continent for now to just avoid all the 54 countries being listed. And then we can enable the filter. Let's just change a couple of things for someone to be able to select more than one continent. If you want to compare the numbers, then you probably want multiple select. So I'll pick this. Then that's it. Okay, so let's look at this. Let's unselect everything. Let's start with Africa. Let's look. Okay, just give it some time. Oh, it has filtered up here. So for Africa, this is what our numbers look like, right? South Africa, we have here in Morocco, there's Kenya here, there's Libya, there's Nigeria, and then we have like the least affected like Chad and Niger. And then also it shows that our chart, right? Like we had the highest peak we had was between 19th July and 20th. It plateaued to go lower, and then we had another spike. I think this is when guys started saying there's a second wave, right? Which is between 25th October and 11th, which is, it was not 11th, first of this month. I think last week we had another spike here in Africa, right? We had 78,000 cases when we had gone to 51,000 and even lower to like 52,000 and 51,000. Then suddenly we got to 78, and then it breaks it down for us by each individual country, and everything else is broken down, including this particular chart. So let me just, this is where you're able to see actually the, the spikes we had in Africa. So there was a spike here, right? South Africa in Q3, had like this huge spike here. There's this other one where some values were different from their minimum and maximum. So box plots are really good for looking at those dynamics. So after that, let me just save this. I'm saying we're almost running out of time. COVID-19 Insights. I'll save that. And then there's also a way of viewing your model or analysis view. Analysis view is like, it takes like snippets or screenshots of what I've done, which is like really good for documenting the work I've been doing, right? Remember, I started with like a geographic data set. I updated it to add location onto it. I created a time series. I aggregated to add a style. Like, it literally has captured my entire workflow as I'm doing it. So after that, I've saved that. Yeah, I think I'm done. So the next thing would just be sharing this workbook. So I'll just refresh my content. Just like any other application you do on ArcGIS Online, anything you save goes to your content. So I'll just go there, or actually I can just go back to my home page and just share the workbook. I think COVID-19 Insights, which is right here. I'll just share this. I'll make it public. I can make it public so all of you can access it. Yeah, I guess that's it. So this is what I'll paste on the chat box. Then you can just see if you can be able to view that or interact with that. I think you should be able to. Let me just use the chat box. Okay. Give me 1 minute. I just come back to the interface chat. Enter. So you guys can try doing that. Sorry, Joy, I've seen your question on how I calculated the rate. So I came here on view data table, and then I said add field. I can just add a field called test, but I'll still use the same calculation because it needs to be a unique identifier. Oh, sorry. Add field. I'll call this field test. And then up here is where you put in the calculation. So if the calculation is like, you can even look at deaths per 1,000 people. So that's deaths, divide by the population of 2019, then maybe I want to look at it per 1,000 people, or just leave it as that, population divided by. So as soon as you do that, then that's how I calculated the rate for insight for that particular field. I hope I've answered your question, Joy. Yeah, I think I'm done for now. Maybe someone can see if they're able, maybe you guys can try and access the link I've just pasted on the chat.